Hi everyone, Clara here. I'm here to talk to you guys today about the differences between alternating current and direct current. So, alternating current is basically a type of current where if you were to map it out, it kind of looks like a little squiggle, kind of like a sine wave or a cosine wave, depending on how you want to interpret it. Whereas DC current, if you were to graph it out or map it out, it looks like a straight line all across. So what that means is that alternating current, the current, the voltage of the current keeps going up and down. Okay, that's why it's called alternating, because it switches from a positive voltage to a negative voltage. Usually, whenever you're presented with a alternating current voltage source, the voltage that it is created with, for example, if you have a positive 5 or a 5 AC source, a 5 alternating current voltage source, it basically means that the voltage can switch from a positive 5 to a negative 5 voltage. And so you have basically like a total of 10 voltages 10 volts that you can work with. DC current, on the other hand, is a type of voltage that just stays constant throughout its entirety of it being turned on. If you have a 5 volt, DC source, you have a total of just 5 volts to work with, okay? So if you have a 5 voltage CC source, you have 5 volts. If you have a 5 voltage AC source, then you have 10 volts, okay? Now, alternating current is very interesting because the reason it is called that is because the current of an AC source, the electrons basically shift, okay, in the direction in which they are heading in the circuit. So, for example, during the time where they are at positive 5 volts, it means that the electrons are flowing in one direction, okay? When it starts going down, it means that the electrons have switched. There are different uses for these types of currents. DC sources are basically you're going to find in a battery. For example, if you have a flashlight or remote controls, just very sort of basic things. Mostly batteries. Those are DC sources. You have just one flow of electrons going through the device it is powering. Alternating current, on the other hand, is used in a lot of very different things. Let's say a ceiling fan, okay? A ceiling fan is oscillating, and it needs AC current to be able to run those oscillations. And things that need oscillations, kind of like a ceiling fan, or anything that needs some sort of alternating. Okay, like I said earlier, AC current, it oscillates between positive and negative. So when you map it out, when you graph it out, it ends up kind of looking like a sine wave. However, if you were to think about it, when the sine wave goes up, if you were to instead go this way, you go back around like this and it forms a circle, right? That's where sine waves kind of come from. It comes from a circle. And so it's basically just a type of current that is going in circles, but it switches directions, right? And because it's going in circles, things kind of like, they need that kind of current to be able to do their job. Now, AC versus DC. There's always been kind of a debate on, whether AC or DC currents are more deadly or whatnot, okay? Now here's the thing. They're both deadly. The reason why AC is said to be a little more deadly is because it requires less milliamps or amperage in general to be able to kill something or someone. Whereas DC current needs more current to be able to do that. So they're both deadly. What matters is just the amount of amperage that is going through the circuit or through the current. Okay. Now the amount of amperage that it can kill a human comes to about 20 to 75 milliamps, even up to 100 or 200 milliamps. In fact, the amount of amperage that can kill a human is actually very low. I thought it would be around 100 amps or maybe 1 amp or 2, but no, it's actually 100 milliamps. That's 1,000 times smaller than what I thought it was going to be. From between 100 to 200, you get a painful shock when it starts to be like 10 milliamps. And yeah, so, I mean, you can get a shock, you can grab onto a wire, but I think usually as long as you let go of it in time, you can kind of be okay. I mean, you'll get the shock of a lifetime. I know there was this one time where I grabbed onto an electric fence for horses. It was crazy. I grabbed onto one and it just kind of shocked me a little bit. You could feel it pulsing, and it was running an AC current, and I could tell because you could feel the pulse just kind of go in and then come out. And then there was nothing for a second or so, or maybe a millisecond, and then you'd feel it again, and it wouldn't shock me very much. However, I did notice that right underneath it, there was another line. So I thought maybe that's the other side of the circuit. So I ended up grabbing onto both of them, and let me tell you, it was not fun at all. Don't ever try that. If you ever see it, it was absolutely painful, and it shocked me back quite a bit. It's kind of crazy. I thought I was gonna die, but it was something else. And yeah, thank you so much for listening, guys. I hope you guys learned a lot, so.
Thank you and have a nice day.